All right, so in this video, we are going to learn how to graph some new interesting types of functions. So we're going to go kind of one at a time, and as we go, we are going to learn some new vocabulary that we can use to describe functions. So in general, if you're faced with a rule where you're like, ooh, I don't know how to graph that, you should do two things. First, make a table. Second, plot the points. At that point, step back, look at it. Does it look like it's trying to do something? Maybe add more points, testing them in the rule, of course, to make sure that they're correct until you get a graph that looks good. Okay, so we're going to start off with one that we've actually been exploring a lot this week, and that is y equals the square root of x. That's what's called the parent function. That's like the simplest of all these square root function graphs. But we're going to change it a little bit. We're going to say y equals the square root of x. How about minus 2? Okay, and then for that one, this is the name of it. I'm going to give you a name for each of these. This one is called a square root function, like so. And so we're going to do our first step, which is to make a table. If in doubt, it's always a good idea just to stick with like -5 to 5, -3 to 3, something like that, until you get a sense of what numbers are going to work and what ones aren't. So go ahead and grab a calculator and calculate those values. Now we're going to be graphing this, so you don't need a whole lot of accuracy. To the nearest tenth would be fine, 1 decimal place. And if you're dealing with something more complicated, it's always good to write it out. So y equals -5 minus 2. Ooh, square root of a negative? I don't even need to graph that. I know that's going to be no solution. So I'm just going to write in an NS. -4, let's do the same thing. -3, same thing. -2, -2 minus 2 is still -4. No solution, no solution, no solution. Now at this point I might be thinking, ooh, I made the wrong table. I maybe should have set this up a different way. So 1 minus 2, -1, still no solution. 2 minus 2, 0. Square root of 0 is 0. Yes! I finally have a point that works. Now I can go from here. 3 minus 2 is 1. Square root of 3 minus 2, square root of 1 equals 1. Fantastic. See, I'm kind of writing out my steps off to the side if I need to do that to keep track, which for some of these you definitely do. 4 minus 2, that would be square root of 2. That one I would need a calculator for. That's about 1.4. Okay. All right, and then I also added 6 because that one's so friendly, right? 6 minus 2 is 4, square root of 4 is 2. So then I'm going to graph. And so I'm going to look at my data values. Don't need much in the negatives. And my positives, they aren't going up very high. I might give myself a little bit more space and just put in some other points that I know are going to work. You don't always have to have them in the table just because you put them in the graph. We'll just make it B. So I decided to go with the scale of 1, and I just went up by, or I started just by graphing the ones that came out nicely, so 0, 2, 0, 3, 1, and 6, 2. And then my other ones here are going to be in between, and I can kind of see where those are going to be a little below half, almost 2, and then I might want to just add in one other point. See if you can think of another point that's going to come out nice. Did you go for 11, 3? That's what I went for. And now once I have them, I'm going to connect the points to make a continuous graph because I know that all those in-between points are going to work. Okay, and there I have my graph of the rule y equals the square root of x minus 2. Now, how can I describe this? So first I can say that it is increasing when x is greater than or equal to 2. You now hopefully know how to do domain and range. So I can say the domain is also x is greater than or equal to 2. I can also say the range is y is greater than or equal to 0. What else can I say about it? I can say that it has an endpoint at 2, 0. Endpoints or starting points are always interesting. Doesn't have any symmetry. Doesn't have a maximum, like a highest possible point. It does have a minimum. The minimum would be like the lowest possible x value, the lowest possible y value. So the minimum is at 0, like so. Okay, let's move on to something newer. All right, this time let's try what's called an absolute value function. Absolute value function. Now, once again, the parent graph, or like the simplest one, would be y equals the absolute value of x. I made it a little bit more complicated. I want you to pause. I want you to try and fill in the table. Okay? Be careful. All right. For x equals -5, did you get y equals 1? That's what we should have had. Because if you put -5 in, -5 plus 1, that's -4. We need the absolute value of that, which is +4, and then -3, which gives you 1. I kind of wrote it along the side. Normally I don't actually do that. Normally I just kind of like jot it off on the side somewhere, but I'm trying to be more organized for you guys. So keep going. If you realize now you did them all wrong, erase, try again. All right, so I just found one of those interesting points. When I got to 0, up until then, it had been going steadily down until it reached -1. And then it changed and it started going back up. Let's see if it continues going back up. And it does. It goes all the way up to 3. All right, now let's go ahead and graph it. So let's set up your graph and graph. And when deciding on your scale, you always want to look. I see both negatives and positives, both negatives and positives. So I'm going to need a 4-quadrant graph. But my numbers are all pretty small. So I'll just continue to scale by 1s. And I'm not marking my scale all the way out in both directions. You absolutely can. It looks nicer that way. But I'm not going to. And it's okay if you don't either, so long as you clearly mark which is x and which is y. Okay? And then you have to have at least one scale marker on each side. All right, so I start graphing and it's going down, and then when I get to 0, it has switched and started going back up again. And it's making this V shape there. Now I can tell by the way this has been behaving that it is going to continue and go out on both directions. You may not fully believe that yet, but you can trust me on this one. It's going to. And I also know that the points in between are going to work. It's going to be continuous. Although I probably should have you test those out so that you believe me. So I'm going to draw them. So here we have an absolute value function. Now go ahead and try and write down a couple statements. Think about the things we said about the square root function. What sort of things can we say about this one? All right, so here are some things that I said. First, the most obvious thing about this graph is that it's pointy, right? So it has a minimum at -1, -3, or a minimum at y equals -3. I think you can explain that both ways. That also happens to be a vertex. We do call it a vertex even when it's not a parabola. It's symmetrical around x equals -1. And we can say that there's like a line of symmetry here, along which we could fold it in half, and that line is at x equals -1. We could say it's decreasing below -1, right? Like it's going down, and then it's increasing above -1. And, oh, and this one has an intercept. I guess the other one did too, actually. Intercepts are always important to point out. So it has an x-intercept, or it has x-intercepts at 2, 0, and -4, 0. So those are over here. and then it has a y-intercept. That means this is where the graph crosses the axis. It has a y-intercept at 0, -2. Okay, go back to your graph from the square root function, and we should add that this one doesn't have a y-intercept, but it does have an x-intercept. Right there, that is our x-intercept. And then we should also practice writing our domain and range. So the domain for this one is going to be all real numbers, because any x value is going to work. It's going to continue out forever. And the range for this one, that minimum is y equals -3. So the range is y must be greater than or equal to -3. Okay, now for your practice problem. So on this one, you are going to graph the rule y equals x minus 2 in parentheses squared minus 1. You'll make a table first, just like how we practiced in this video, being very careful with your order of operations, writing out all the steps if you need to. Then you'll make a lovely graph, adding more points as needed so that you can see what it looks like. Then you'll write as many descriptive statements as you can. And I've summarized all of our new vocabulary below. So we talked about the vertex, we've talked about symmetry, intercepts, both x and y, whether it is increasing or decreasing, right? You always judge that going from left to right. Whether there is a minimum value, a lowest possible point on the graph, or a maximum value, a highest possible point on the graph. And then you know about domain and range from the earlier video. And then vertex, that word hopefully came up at least once in 7th grade, but that the vertex is like the peak of a mountain or the base point of a valley, right? So it applies to the absolute value graphs as well as to parabolas. All right, good luck. And you're going to write those descriptive statements in the text box of the homework turn-in on Canvas. Okay? Thank you.